Okay, so simplify the following. So these are just expressions, and we're trying to simplify them. Okay, so an expression is that it doesn't have an equal sign. Okay, so 20C4. I'm going to look at my formula sheet. And here is the formula for combination. So it's going to go 20 factorial divided by 4 factorial, 20 minus 4 factorial. Okay, that is the formula from a formula sheet, so you would have that in front of you on a test, right? Okay, everybody would understand that that should be 16 factorial. Okay, I'm now not going to ever write that again. I usually just do like straight into a 16 factorial. Okay, I am not going to divide. I'm going to times and flip. Is that the same process? That makes sense to you? Because there was some other stuff here. I'm dividing by these things. So instead of dividing by these things, I'm timesing by the flip fraction.
So why can't we just like use the formula? Like we have it in our calculator, right? Can't you just punch in 20C?
No. It'll say to like show all your steps. Yeah. Okay. Now, here's the trick with factorials. I need you to expand the larger factorials. So what would be the factorial that you would attack? I'm going to do 20. It's the largest one. So how do you start expanding a factorial? So 20 times 19 times 18 times 17 times 16 and beyond. What gave me the hint to stop there?
The 16 at the bottom.
The 16 factorial at the bottom. Okay. I'm also going to expand 4 factorial. 4, 3, 2, 1. I'm going to leave 16 factorial. Okay, now I'm going to start canceling stuff. You ready? 16 and beyond. 16 and all the stuff after it. Gone. I'm going to cross off a 17. I'm going to cross off a 19. So if you don't have a calculator, what are we doing here? So this is what I'm left with after those cancels. Okay, you ready? I'm not touching my calculator yet. Would we agree that this 3 times 2 is really a 6? That's like a 6. What if I take a 6 out of the top and bottom? I'm going to cross this off and put a 3 and completely cross that off. Then I'm going to take a 4 out of the top and bottom. So what happens if you take a 4 out? Cross off and put a 5, cross off completely. So what does the whole thing come out to be? 15. That's all you're left with now. All without a calculator.
Why is it 17, 1 over 17 times 19 rather than 17 times 19?
Why did I write that as a fraction?
Why would you do it?
Because it really is like that. in the original question. Is that, do you see it like that? Okay, number 2. I'm going to expand the larger factorial. So which factorial is larger? So you actually only have 2 factorials that you're looking at, so that one and that one. So which one is a larger one? N plus 3 is larger than n. Okay, so we're going to start. N plus 3. Remember, we're going downhill. So what's one lower? N plus 2. What's one lower? N plus 1. And then n and beyond, right? I'm going to stop there. Do you see why I'm stopping there? That's matching with the one on the bottom. Okay, so we expanded the larger one until we knew when to stop. So the n factorial would cancel. This factor would cancel, n plus 2. And you're left with an n plus 3 and an n plus 1. Okay, so now the word simplify, what does it mean to you? So if I tell you 4 times 5 and I say simplify it, what would you do? 20, because what did you do? You multiplied it. So we are going to multiply these, so that means I need to FOIL. I get a lot of confusion with students who try to factor. Factor is actually the opposite of simplifying. Factor is making it more complicated, okay? So foiling and factoring are opposite. So remember the word simplify. What does it mean? Okay, next one. N plus 2 and n. So which of those 2 factorials is a bigger one? The top. N plus 2. Let's go down from that. N plus 1. And then just an n. And then there has to be a factorial symbol on there to say that this pattern would keep going. And then the factorials would cancel. And then because the problem says simplify, then you need to multiply what you would have left. Okay, the next one. You have 2 factorials. Which one is bigger? N plus 1 is a larger number, right? So I'm going to start there. I can actually just rewrite the top. Okay, so n plus 1. If you go down 1 from that, you are at a n. If you go down from that, you're at n minus 1. You get a cancel, and this is where lots of people lose marks. How to write the final answer here. This is what I get a lot of, and it's wrong.
It has to be 1 over.
1 over. Yeah. Do you see that common mistake? People just see, oh, I'm left with this. I write that, but don't forget it's a fraction, so it's a 1 over. Okay, so now we're going to take that kind of thing into equation solving. Okay, so same strategies. You expand larger factorials. So I'm going to go with an n plus 2, and I'm going to expand it. N plus 2, and where do I stop my expansion? Whenever I meet up to another factorial that I see. So n plus 1, n minus 1, and beyond. Okay, so same stuff. Expand larger. Okay, now I'm going to cancel on both sides, so n minus 1 factorial could cancel away. N plus 1 can cancel away. And I'm left with these two items, so I'm going to times them. I'm going to distribute them out. Okay, now this is the real test. Do you remember anything from grade 11? What do? Equals 0. Yep. As soon as you see two variables, you got to have a 0 on one side, right? So equals 0 is your first instinct, and then you look to factor, and then you say, what style is it? Well, this is a simple. So 7 times 5. So n equals -7 or n equals 5. But this one won't work if I plug it in, because if I make -7n and I go here, -7 plus 2, well, that's -5 factorial. And what do you know about factorials? Where do you always stop with your numbers? 1. 1 is the lowest you can ever get to, right? So you can't do a negative number. Okay, and the last question. NC2, so we're going to have to go to our formula sheet. So it would go n factorial divided by 2 factorial n minus 2 factorial. So what did I do there? I just grabbed my formula sheet and figured out what to replace with. Okay, strategy. Expand the larger one. So n is larger. What is 2 factorial without your calculator? It's just 2. Okay. Once you've expanded, you have something that cancels, right? Cancel, and I distributed what I had there. Now, what would be a good just algebraic strategy? This is old stuff, thinking of what to do algebraically. What would be a good strategy here? Times by 2? Is that what you're thinking? Timesing by 2 would be a good idea. So then that gets rid of my fraction. And then we would 0 it. And then factor, right? Okay, now with this unit you have to be careful just to think about this. 10 choose 2, that makes sense. -9 choose 2, can that be possible? No. Can't have, this one can't be smaller than that one, right? Can't be smaller. Okay, I'm going to do a couple in your notes maybe with you. Yeah. What? Okay, expand the larger one, and here's where people get tricked. Which one of those is a larger number? Is n minus 6 or n minus 4 would be a larger number? N minus 4 is larger. That one tricks people because they see 6 and then that thinks, oh, 6 is a larger number. Just think about this. If n was a random number, you can make n anything you want, like 20. If it was 20, this would be a 14 and this would be a 16, making it larger. So that means we're going to expand that. So what's lower? What's lower? And then we stop. And then we can cancel. And then we look for a match. So then the answer should be number or letter B. Okay. On page 1, sorry, I got your writing in here. On page 1, you can do this question now. What does the word evaluate mean? Evaluate in math means you should come to a number answer.
Is that your writing?
No. Griffin's.
Wow, it looks really nice.
Evaluate.
That's pretty good writing.
Matters. Evaluate, and you wrote matters.
Exactly.
Okay.
Good job, Matt.
So you, what are you going to do on this question then? You're going to use the formulas. Okay, grabbing your formula sheet. N factorial. So this would be 7 factorial. Can we do the subtraction? N minus R. So 7 subtract 2 is 5 factorial. Divided by. So that was just the top. What's the formula for the bottom? So n factorial, 7 factorial over, and then subtract. So what's 7 subtract 5? 2 factorial. Okay, then you should do a times flip on this. That would be your next move. Whoops, don't want that in there. Times flip. This cancels completely. And then you're left with this and this right now. Which one of those should I start expanding? 5. So 5, 4, 3, 2, and beyond. So I'm doing all of this all without my calculator again. Cancels, cancels. Would you agree your answer is a fraction like this, 1 over?
Yes.
And then you can do this in your head, I promise you. What's 5 times 4 I would do first? 20. And then 20 times 3 or 2 times 3, 6, so 60. And then evaluate. So look at our end result, a number. That's what evaluate means, get to a number. Okay, so flip to page 11, which is all of this kind of stuff, 11 and 12. Pick me one of them that looks super crazy. Page 11 or 12, you can pick me anything. Anybody want to try, which one? 3? 3. Page 11, number 3. Okay, formula. So this is a glued together. So instead of n, it's actually n minus 1. Do you see that? Whatever the first number is, factorial. So the first thing factorial, over, okay, I'm going to read it not with n's and r's. I'm going to say the first thing minus the second thing factorial. So how do you write that? The first thing minus the second thing factorial. So do you see how that formula is used? But it's tricky because instead of an n, there's an n minus 1 in that place. So now that's going to turn that into an n minus 3 factorial. Okay, so again, this formula is all about the first part factorial, and then here is always the first part minus the second part factorial. That's really how you should think about it. Okay, which one do we expand? What's bigger? The top. So n minus 1 and down. Cancel. Then you should FOIL. Then you should recognize two variables. Boom equals 0. Then you should be able to factor. All this should look very familiar. So now you have to input those in to say, like, does that make sense in this situation? So if n was 8, this would be 7p2. I can do that. -5, this would be -6p2, and that does not work. It's not possible.
So if it's negative and over.
It's not that the answer is negative, because if I had something like this and I got a solution of n equals -5, that can still be a solution. Do you see it?
Yeah.
Because if I put it in, it would be 2, and I can do 2p2. So it's not that this is negative, it's just that when it was in there, it was negative. Okay, and then I'm going to give you some hints. Sometimes if you get fractions, don't forget you can do this equals this, like a cross multiply strategy. So if you ever run into fractions, your algebra can be cross multiply this equals the cross of this. You know that strategy that I'm talking about?